Let's pick up where we left off from our last lesson. Still in section 1-2, where we're measuring segments. So if you remember, we were talking about the segment addition postulate previously. We're looking at another problem. This is example 3a in your notes. And let's read through this. Y is between x and z. We know that xz is equal to 3 and xy is 1 and 1/3. We want to find yz. So let's read through this again. Y is between x and z. Okay, let's do a little drawing here. Okay, doesn't have to be fancy, just real quick. So we know at the back end we have x, front end we have z, and y is somewhere here in the middle. Okay. The entire length is 3, okay? But from x to y, it's only 1 and 1/3, okay? When you're doing these geometry problems, it is extremely important to do the drawing, the labeling, and the algebra work behind it, okay? So I'm going to put a little note here. Number 1, draw. 2, label. Label the points, label the measurements that you have. You can even put a variable for an unknown. Let's put x in here for this for right now. Or you could actually use our geometric variable, which would be yz that we don't know. Okay, and 3, algebra. Okay. This part you've done in previous courses. This is part kind of what we're learning now in that transition from there to there. Okay? All right, let's keep going. A little side note there for you. Got our drawing. So we're going to use that segment addition postulate like I told you before. We know the full length is xz. The two parts are xy and yz. Let's fill in and substitute for our geometric variables. Okay, so there's our 3, 1 and 1/3, and like I said, geometric variable here, not a name, just a geometric variable, yz. That's why we don't have lines above them when they're geometric variables. All I have to do at this point is go back to my algebra skills from previous courses, right? This here is the geometry. Writing this out and then transitioning back into algebra class, okay? So, we want to solve for yz. We want to know that length. So we're going to subtract the 1 and 1/3 from both sides. Make sure you're showing this. I know some of you may feel like you can do it in your head or quickly on a calculator. I'm going to ask you not to do that. Please show that work, okay? That is the biggest, probably, culprit to students not performing well in math classes, and it's something I reiterate over and over with my tutoring students. That is the biggest growth we make with my tutoring kids, is showing our work. Okay? Freebie for you. You don't have to pay the $40 and $50 an hour to me. Okay, so when we do that, we're going to end up with yz being equal to 1 and 2/3. Okay, our next example here, example 3b, I'm going to let you try and work this one out on your own. So if you'll do me a favor, go ahead and pause the video at this point, and I'll come back to you shortly. Okay, let's follow along at this point and see how my process matches yours, where there's differences, and where we can kind of clean things up. Okay, so first things first. We are going to start with the segment addition postulate again. We're adding these two segments together to equal the total. So we're going to substitute the values that we know. Again, they're expressions that are given. Okay, at this point, we've got the algebra written. We just need to simplify and solve. And I'll go through these steps fairly quickly. Make sure you're showing this work. If you didn't, you may want to write down the solution separately to the side. And you should get a final answer that x is equal to 4. Okay, so we still need to find the other lengths, right? We still need to know the full length from D to F. We've figured out what x was, right? It's 4. All we have to do is substitute that in, and we get an answer of 24 units. Okay, keep moving here. Let's get to some new vocabulary. The midpoint, M, of AB is the point that bisects or divides the segment into two congruent segments. If M is the midpoint of AB, then AM is equal to AB. This works well with a picture, I think, and we'll do it right up here. If we have a line drawn here, and I'll put some endpoints in, we have A and B, and then we have a midpoint. Okay, this midpoint is exactly at the center. Okay, it's not just in between, but it's exactly at the center. And we'll call that midpoint M in this case. Okay, so the two segments created by AM and MB, they're congruent. And remember, we use tick marks to show congruent segments. All right. Example 4. This is an application problem. So the map shows the route for a race. You are at X, which is 6,000 feet from the first checkpoint C. The second checkpoint D is located at the midpoint between C and the end of the race Y. The total race is 3 miles. How far apart are the two checkpoints? Okay, so we're at 6,000 feet. Okay, 6,000 feet. And I have a little note here, convert race distance to feet. So we need to change this 3 miles into feet, okay? This is the beginning, this is the start, and here's our end, okay? Start and end, that's a total of 3 miles, okay? The first checkpoint, 3 miles, well, that's not a very good 3, let's fix that, 3 miles. This is 6,000 feet, and so we'll have to convert that 3 miles to feet. Okay, so we can do that through multiplication. If you remember, 1 mile is equal to 5,280 feet, so we'll do that multiplication. We know the total distance of the race is 15,840 feet. Okay, let's use that. Okay, so from XC, right, XC, that's the first checkpoint. If we add that to the remainder of the race, we'll get the total distance. So let's substitute our information in. So for XC, that first geometric variable, we're going to put 6,000. We'll leave CY as a geometric variable and then put the total for the race. Now we're just at the algebra part. Okay, all we need to do is solve for CY here. So we'll subtract the 6,000. We end up finding that CY is 9,840 feet. If you remember from the information about the race, that D is the midpoint, right? D here is the midpoint from here to here. It's in the middle, so guess what? If we want to find those distances, we can rewrite that CD is 1/2 of this total. It's 1/2 of that full distance from C to Y. Okay, so 1/2 of, right? Of means multiply. So if I take 1/2 of that, or divide 9,840 by 2, we end up with 4,920 feet. So the checkpoints, right? Checkpoints C and D are 4,920 feet apart. Okay, D is the midpoint of EF. We have some information about ED and DF in this example. I'm going to have you pause the video here, Work this one out on your own. Let's see what you come up with, and just give it a shot, okay? Okay, we're back. So in this case, this is a little bit different, and you may have been pretty confused on how to do this, but we do know, right, that when we have a midpoint, these two segments, right, ED here is congruent or equal to DF. Okay, so we can set it up that way. So we're going to solve for x here. D is the midpoint of EF, so we write ED equal to DF. Okay, and our next step is going to be substituting in the expressions. Once we have the expressions, right, two expressions are equal to each other, make it an equation. We just need to solve that equation. So I'm going to subtract 4x from both sides. You may have started at a different point. That's fine. You can do that. Maybe you subtracted 6 from both sides first. Perfectly fine. We should get to the same final answer. 5x. Okay. Reminder, make sure you are showing this work. Do not skip showing all of this work here. All right, so we know what x is, but we still need to find out what those lengths are. Piece of cake. We can all do this. It's simple and easy. We're going to substitute that length of x in, which is 5, and simplify. So ED is 26, and guess what? I'll bet, even though I can substitute, tongue twister there, 5 in for x for DF, it should also be 26. Okay. So when I start to know my geometry much better, I'll really only need to find one segment if I have a midpoint, because I'll know the other segment is the same. Okay, so if I add them together to get the full length, we have a length from E to F, which is 52. Okay, let's keep going. Example 5. Okay, so again, we have a midpoint. We have two segments here. They are equal to each other. And we'll show that with a little tick mark here, right there and right there. So let's set this up. We know that both segments are equal. S is being the midpoint, so we're going to write our geometric equation, right, with our geometric variables, and then transition it into algebra. So we'll do that by substitution, and then it's a matter of solving our algebraic equation. And we end up with x equal to -2. We are not finished though, right? We still need to find all of these lengths. So let's go through and do that. Substituting x for those values. For RS, we'll end up with 4. ST, we also end up with 4. Imagine that. The total length from R to T should be 8. Okay? Now, if you ever go through this and you get that other side doesn't equal, you know that there should be a question. What is going on? Why did I? And that finishes up our lesson for section 1-2.